Hello and welcome to the first class on aldehydes and ketones. We had finished so far 12th, 12th class organic chemistry, beginning from haloalkanes and haloarenes. Then this next chapter was alcohols, phenols, and ethers. After that, we are starting aldehydes and ketones. This will be a big one, but we will try to make it as uh, you know, intensive and fast as possible. I am sharing the screen, and to begin with, this, as you know, is a carbonyl group. As long as it is not bonded with any heteroatom, another heteroatom like oxygen or nitrogen having a lone pair, it is called a carbonyl group. Once it is bonded with a lone pair and a conjugation happens, resonance happens, conjugation happens, and that is not called a carbonyl group, it becomes a carboxyl group and its derivatives. Properties get completely changed. So, carbonyl group, you have the other side is hydrogen. This is aldehyde, as you already know, and the suffix is al. And if both the sides are carbon chain, then they are ketones. And this is ONE. As you know, to delete E, for example, we go for the nomenclature for revision. Oh, because aldehyde group always comes first, irrespective of where it is. Maybe the longest chain, may not be the longest chain, but that is a type C group. And so also this one. And same will be case of, it is, supposing it is, I am giving you a substituted ketone, aromatic ketone, and an aromatic aldehyde. So what is the name of this compound? It will be aldehyde carbon will be always by default, it will be 1. Then longest chain 1, 2, 3, 4. 1, 2, 3, 4, 5. So this will be propan 2-il or isopropyl. So 2 propan
Propan
2-il
doing
or isopropyl
pen.
or 1-methyl ethyl, as still people call it, but I don't. You can write isopropyl, no harm, everybody will understand. And then this is pentanal. And this own ketone should be given the lowest locant. So we'll start from here. 2, 3, 4, 5, 6, 7, 4, 5, 4, 5, 6. So we have to go this way, 4, 5, 6, 7. So this becomes, sec butyl, or sec butyl. If you don't want, then you just tell butan 2-il. Yes or no?
Yes, sir.
So this will be uh, 3 butan 2-il or sec butyl, or it will be 1 methyl propyl butan 2-il, then 3 methyl once again, then heptan. There are two N's. Heptan, E will be replaced by ONE. And what is the locant of own? That has to be mentioned.
Two.
Even if it is one, one happens only when there is a cyclic group like phenyl or cyclopropyl or anything. Then only one one will come. Otherwise, if it is an aliphatic carbon chain, then always it will be minimum 2 or 3 this heptane 2 and this is acetophenone. You of course to be very this is 1 dash 2 dash. This will be 2. Of course, 1 carries no meaning. 2 nitrophenyl ethanone. Ethanone has to be 1 on. This will be the IUPAC name, but it will be, you can call it ortho or 2 nitroacetophenone. And this will be 4-methoxybenzyaldehyde, right?
Yes, sir.
Are you able to see the screen
Yes, sir.
completely?
Yes, sir.
3-methoxy acetophenone. Sorry. कौन 4-methoxy? What? 4-methoxy what? Huh? 4-methoxy what?
Sir, Benjamin.
Benjanone.
Nal.
Benjanal ଗୋଟେ କଣ ଥାଏ? There is nothing called, you can call it, call it benzene carbaldehyde, you can call it. Ka, you can do it. Otherwise, it is benzaldehyde, right? You already know, but
Yes, sir.
your organic pocket is very now going weak. That gives me enough dissatisfaction. This is benzaldehyde. Cannot be benjanal. And there is nothing called benjanal. If you want to be very keen about using benzene, then benzene carboxylic acid, benzene carbaldehyde. That is called benzaldehyde. There is nothing called benjanal. You can,
Yes, sir. Benjamin.
Tale, why are you, uh, you know, breaking the speed? Right?
Yes, sir.
So 4-methoxy benzaldehyde. When you look to the methods of preparation, many of the methods of preparation we know. Let us list those which we already know. We will not discuss more about that. Number 1 is oxidation of alcohols. You already know that 1 degree alcohol is oxidized to aldehyde. Of course, you have to have a specific reagent. Um, 2 degree alcohol ketone. As we already know, if you use Jones reagent for 1 degree alcohol, then that will Jones reagent, which is CrO3 plus sulfuric acid in acetone, and of course some water will be there. It is not usually written. That will oxidize aldehyde further to carboxylic acid, so that is avoided. Also, you can use in its place potassium dichromate. In some books you will find simply as we use in inorganic reactions. They write, but usually such things are not done in organic reactions. Jones reagent is the choice, but you can write down potassium dichromate sulfuric acid. So, if Jones reagent is used, then you have to quickly remove uh, Jones reagent যদি for aldehyde যদি use করিব, then excess of 1 degree alcohol নব, because and the aldehyde product is quickly removed. Excess of aldehyde product is quickly removed, not allowed to further oxidize. It is better to use specific reagents, but specific reagents like PCC, pyridinium chlorochromate, PDC, pyridinium, this you already know, this is pyridinium dichromate. This is pyridinium dichromate is something like this. This is C5H5N, and this ammonium salt becomes NH plus. So since dichromate has a valency 2, so this is pyridinium dichromate. And this PCC is pyridinium chlorochromate, consists of CrO3, pyridine instead of acetone, instead of sulfuric acid, you have pyridine and HCl. So it forms this. You can also have another substitute, MnO2 in acetone. It doesn't affect CC double bond conjugated. Does not affect the CC double bond, conjugated double bond. The other one, the latest one is DMP, Des Martin per iodine, iodinane. DMP is the best one. Remember, PCC can also, sorry, PCC, NB. PCC can also, and also PDC can also oxidize. That is the beauty. 2 degree alcohol to ketone. 1 degree alcohol, it takes to the aldehyde stage, not further oxidized. But 2 degree alcohol, it oxidizes to ketone. So some guys have a belief that PCC is only meant for 1 degree alcohol. No, it can also be used for 2 degree alcohol. You can pyridinium chlorochromate. This will give you this one, pyridinium NH plus, and this will be the chlorochromate is this. there will be one Cl and one O minus. So plus here minus. This is the formula pyridinium chlorochromate. Chlorochromate. CrO3 minus, and this is pyridinium C5 H5 NH plus. And desmatine periodane is a very typical structure that is having a benzene ring and an ester structure, and of course, interestingly, iodine is there. It's very complicated structure, and there are three acetate group. Such a complex structure. This is famously called thus Martin per iodinane. That nowadays is very, very popular for selectively oxidizing 1 degree alcohol mm, to aldehyde. Now you can, in the file, you can find the mechanism how Jones reagent, which is chromic acid, in fact, chromium trioxide with water in agents of acid gives chromic acid H2CrO4, and then this primary alcohol here, or secondary alcohol, whatever. Here secondary alcohol is taken. So the lone pair attacks to chromium, and it goes OH minus goes as water, and then this O carries plus, and there is deprotonation. Then the base, which is HSO4 minus, sulfuric acid, the conjugate base is HSO4 minus. Abstract a proton in case of 2 degree, there is one hydrogen that it is abstracted by HSO4 minus, and this goes here, and this goes here, and this goes here. So this HCrO3 minus that goes, we are not interested in that, so we get a ketone. Had there been another H in 1 degree alcohol, there will be another H here, so you get aldehyde. But Jones reagent, if you prolong it or if you have insufficient alcohol, 1 degree alcohol, then the product will be exclusively carboxylic acid. So you need not write down the mechanism. I'll just give you, and here you can find the what happens when PCC is taken, why it is arrested in the stage of aldehyde. We have used a cyclic compound. Doesn't matter, same principle. O attacks to the chlorochromate chlorine, and then this pi bond is polarized. You find here O is plus. Pyridinium always remains as an ion pair together. Then there is a proton transfer. You see here, this this O loses proton, and it goes here. It's not shown. We can show it. No problem. You can show it one of this, so that you get this one, and then this minus charge comes here, and chloride ion is removed. The chloride ion is removed. Here you find there is no chloride ion connected to chromium. Chromium has lost all chloride ion. There is a two double bonds, and then chloride ion acting as a base abstract one of the protons of the primary position, and here, and this bond breaks. This pi bond, this sigma bond becomes a pi bond, and you get aldehyde separated, and this bond also breaks. So you get chromium 4. It's 4. Chromium is reduced from +6 to +4. And of course, if you find the oxidation number, carbon here in 1 degree carbon, the oxidation number is oxidized. Definitely it is oxidized. So you get the benzaldehyde. This is the interesting mechanism, but this Pyridinium chloride is always there. Chloride ion is already lost, so they are friends now. So these two are the other products, and we get our benzaldehyde. So you need not write the mechanism I was telling, because uh, you can take examples. 1 degree alcohol gives PCC, PDC, or DMP gives aldehyde plus water. Jones reagent can be used for 1 degree alcohol having conjugated C double bond C. So that is an interesting thing, that if there is a double bond conjugated, then you can use. That's a very peculiar thing that I have found out for IIT Advanced. Jones reagent will convert a 2 degree alcohol to ketone. PCC can also be used, I have already told you. Jones reagent can be used when there is C double bond C is conjugated. PCC can be used when C double bond C is unconjugated. So, if there is a double bond, then you have to use Jones reagent for the purpose. So the double bond is retained. That is retained. But if it is unconjugated, then it is better to use PCC. Write down this because it is already written. Then the second is, again, catalytic dehydrogenation, 1 degree alcohol, copper, heat gives you aldehyde, no further oxidation, 2 degree alcohol, ketone. 3 degree alcohol, we will not be interested because it keeps an alkene containing same number of carbon atom due to dehydration, that we know. Excuse me. Let me know when you finish it.
Yes, sir.
It seems that some unit tests might be going on in DAV schools. So they are unable to now sustain the extra load. It's not that easy. When you are, faltering, organic is not strong now, but I'm sure you can capture it. I'm sure within some time you will be strong in organic, because organic is the main, the vital. Or because physical, a good student in mathematics can do it, in physics. Inorganic, yes, you can revise and revise again and again. For inorganic, you know the logic, so equation writing, balancing will not be a problem. And but organic, you must be thorough just by revising the reactions, writing down, and solving problems.
Yes, sir.
And this one also is known to you. Ozonolysis of alkenes will give you a mixture of aldehyde, ketone, depending on the alkene used. I've shown you an alkene which will give you an aldehyde and one ketone, but it can be two same aldehydes, two same ketones, one aldehyde, one ketone. So, but that should be reductive ozonolysis. You have to use zinc water or zinc acetic acid so that it will not oxidize aldehyde further to, sorry, it will not, it will not oxidize aldehyde further to carboxylic acid. So that hydrogen peroxide produced is eaten away, is removed by the reaction with zinc, acetic acid or zinc water. This also, hydration of alkynes with using mercuric sulfate, sulfuric acid, and mild warming, 80 degrees Celsius. You get enol, enol gets converted to keto form. It is only the acetylene which gives acetaldehyde, but others gives ketone. If it is a terminal alkyne, it gives a 2 on. It gives always 2 on. But is if in internal alkyne you get a mixture and that is unsymmetrical like pent 2 wine, you get both pentan 2-one and pentan 3-one. You can't arrest it. You get a mixture of two, but that is why it is suitable for terminal alkynes to get 2 ones. Over.
Yes, sir.
Jyoti, whenever you find you are slowing down or I am going fast, then you leave space. No problem. These are things which are already done. And this is important. This is the first time that we are doing calcium salt. Calcium is divalent, so it will take two alkanoids. So some people put two covalent bonds, but usually it is ionic. But to show, you can put two covalent bonds. So calcium salt of carboxylic acid on heating, salt of carboxylic acid. Calcium salt, I mean salt of. If you simply heat or distill, dry distill, no addition of water, then calcium carbonate ମୁଁ ଯେମିତି ଦେଖେଇଛି elimination. The elimination of calcium carbonate occurs as it remains as a residue and the ketone gets distilled out. But if you take a mixture of calcium salt of any carboxylic acid as well as calcium formate, calcium salt of formic acid together in 1:1 ratio, then you see how I have rounded off. One calcium carbonate from here, the other calcium carbonate will be here. So there will be 2 moles of aldehyde. R gets connected with CHO. These are connected with this CHO. So you get two aldehydes and two calcium carbonates. If you heat only calcium formate, then removal of calcium carbonate, sorry, removal of calcium carbonate will produce formaldehyde. Write down. So this is the first method which we didn't study earlier. But all the previous methods, all the 4 methods of preparation of aldehydes and ketones, we had studied, but here we are discussing little more how a double bond conjugated, if you have a secondary alcohol, then you can use Jones reagent without affecting the conjugated double bond. But if you have unconjugated, Jones reagent will rupture it, break down. So in that case, you have to take PCC. But that doesn't say the PCC cannot be used for a uh, you know unconjugated one. But Jones reagent cannot be used for an unconjugated one. If it is double bond is farther away, miles away, not conjugated, then that bond will be broken by Jones reagent. So that is why PCC is used when it is unconjugated. But conjugated, now there is a resonance mechanism. In that case, Jones reagent will not be able to break that double bond and will oxidize the secondary alcohol to ketone.
Yes, sir.
Well, This also we have done. Sixth, by Walker's method, Walker's process of getting alkenes into aldehydes and ketones. Only ethylene will give you acetaldehyde, and all terminal alkenes will give you 2 ones. This is suitable for terminal alkenes. We'll use oxygen, water, and the catalyst is PdCl2 and CuCl2, and that will give you this. This we know. I think Walker's method हमें पढ़ते ले अगुरु.
Yes, sir.
We are not going to have the mechanism of Walker's process now, but if you want, you can easily understand. And the next one is interesting. From Grignard reagent with acid chloride, ester, alkane nitrile. Of course, hydrogen cyanide is another nitrile. Hydrogen cyanide is not called nitrile unless there is another carbon at least. It's not methane nitrile. You can't call it methane nitrile, but it is, sounding weird, ridiculous. It's an inorganic compound. Methane is an organic compound, so methane nitrile, if you say, it sounds very ridiculous. So if you take acid chloride, we will not study the mechanism. This will be acyl substitution. But once we are handling a carboxylic acid a derivative, the substitution that chloride ion will have is different. So to show it in a very uh, shortcut way, I have shown two arrow marks at the same time that this Grignard reagent, the carbanion will attack as a nucleophile, and this in the first step it will be polarized to O minus. Then the next step it will come back again and Cl minus will go. I have shown in one diagram. The two steps have been depicted in one diagram. So Cl minus will join with the other part MgX. If it is MgCl, there is MgCl2. If MgBr, then MgClBr, and so on. These are all ionic compounds. Forget about. Also, the same thing will happen with ester. Ester also will go as alkoxide. That will be joined with magnesium alkoxide ion. So Grignard reagent, as you know, is an organometallic compound. So you can also use dialkyl cadmium in place of Grignard reagent. One of the R will be active, the other R will remain with cadmium. So same thing will happen. One R minus will attack to either you are taking acid chloride or ester, you get ketone. Only ketone in this case. Acid chloride and ester will give only ketone.
Yes, sir.
And I have shown another one. The heading is acid nitrile. Acid nitrile also will produce triple bond will become double bond, then on hydrolysis, then it will become imine double bond NH, which again on hydrolysis, because the alkylamines are very unstable on hydrolysis, this bond will break and it will form ammonium ion in multi-step mechanism. I'm not showing that, and O will be attached here, so it will be ketone. So cyanide, ester, and acid chloride, all the three will produce ketone with organometallic compound like Grignard reagent or dialkyl cadmium. And HCN, since there is one H in the same method like RCN, Grignard reagent will give you, same imine method will give you aldehyde. If you use HCN in place of any other alkyl cyanide, you get aldehyde.
sir.
So, you finished?
Yes, sir.
Now, this we have already known, but hydroboration we knew, but hydroboration using Cr2BH we do not know. This is a new one only for, aldehydes and ketones. Mostly used for aldehydes, terminal alkynes with a very selective and hindered diborane, borane, not diborane. This BS3, supposing it is BS3, two hydrogen atoms were replaced by Cr2, dicyamyl borane, not diborane, dicyamyl borane, a selective hindered borane, same thing. The advantage of this is that it will not make the double bond single bond. If you take only borane, then another addition of another that was happening in alkene to produce trialkyl borane, all single bonds. But here there will be no further addition because of the steric effect. You know, after I have not shown this step, it becomes alkenyl borane, alkenyl, this B, Cr2 will be there because there is one hydrogen. So there is no room. This is B, Cr2. The only question is another Cr2BH, can it be added H here? And no. Because of the steric crowding, steric hydrons, this will remain here. And this is enol quickly transforms into aldehyde. The similar manner, internal alkyne will give you ketone. Of course, if it is a symmetrical one, you get one ketone. If it is an unsymmetrical one, you get two ketones. I've just written showing that, excuse me, I've taken a non-symmetrical ketone. That is why two ketones. But these are actually more valid for the terminal alkynes giving you aldehyde. Ketones, we have mercury sulfate sulfuric acid method. That is more elegant. Why to go for such a high cost dicyamyl borane? Why not mercury sulfate sulfuric acid? If that will give you ketone, why to go get this? So terminal alkynes can give. If you take mercury sulfate sulfuric acid with this, any terminal alkyne, it will give you 2-on. But in this method, you will get aldehyde. You understand?
Yes, sir.
That is the big difference. If you have propine, then you will not get propan 2-on. Had you taken mercury sulfate sulfuric acid, then you would have got propan 2-on. But here, this method is selective to triple bond. So all addition will be taking place at the triple bond, making a double bond. In all, then tautomerizes to aldehyde. Write down. And dicyamyl, this is cyamyl. That is di. This is 2. For 2, it is di. Sec isoamyl borane. There is a secondary carbon here, CH. Secondary alkyl group here. Not carbon, secondary alkyl group here. And also iso. So, di sec isoamyl borane.
Yes, sir.
Already done.
Yes, sir.
So soon. And this is very important. Periodate cleavage, this is important for IIT Advanced. Whenever there is a vicinal diol, this vicinal diol and you treat it with periodate ion, maybe periodic acid or sodium periodate, then the CC bond will break down, and these two will be converted to the carbonyl compound. And if there is a hydrogen here, there is one hydrogen here not shown, it will be aldehyde. If there is a methyl group, it will be ketone. Since it was a cyclic compound, it became acyclic with the two different aldehyde at the two terminals. But if it is an acyclic compound like this, 1, 2, 3, 4, 5, pentane 1, 2 diol, it should be 1, 2 diol. Then that breaks down, this part will become aldehyde, 1 carbon aldehyde, and this carbon will become 4 carbon aldehyde. And if there would have been any methyl group here or methyl group here, then it would have been any other aldehyde, or here if there is a methyl group, it would have been a ketone. You can use, in place of periodate ion, you can use lead tetraacetate. This is a strong oxidizing agent. Lead is in the +4 state, and due to the not pair effect, it quickly goes back to +2 stage, and hence acts as a very good oxidizing agent. Can be used in place of periodate. Write down periodate, not periodate, periodate.
Yes, sir.
Now, this is only for aldehyde. This is common for aldehydes and ketones. This is only for aldehydes. Rosenmann's reduction is very typical of getting aldehyde. May it be aromatic, may it be aliphatic. You have to use acid chloride, alkanoyl or benzoyl chloride, DE. DE is missing. So if you take palladized barium sulfate or palladium calcium carbonate, this is the Lindler's reagent as we call, poisoned by quinoline and sulfur, you get this chlorine is replaced by H. Nowadays it has been found that hydrogen palladium, only palladium can also be used. This is used when particularly the poisoning and all that barium sulfate is mostly required for converting a triple bond into double bond selectively, and that gives cis alkene. For that, barium sulfate poisoning with some poison, catalytic poison, these are important. But for acid chloride converting to aldehyde, simply H2PD can also do. Benzoyl chloride will give benzaldehyde. Stephan reduction is very interesting. To get an aldehyde from alkane nitrile or alkyl cyanide, you have to use selective reducing agent stannous chloride and HCl, not tin HCl. Very strong one. Stannous chloride HCl will produce, you convert it to imine. As if one hydrogen here, one hydrogen here. I have not shown the mechanism. Imines are very unstable in acidic medium. It undergoes cleavage to produce aldehyde and ammonia. Of course, ammonia cannot fly because it is acidic medium. It will remain as ammonium ion. Right now, it's called Stephan's reduction.
Yes, sir.
Now, this is very important. Diethyl hydride, you have seen, another, hydride, lithium aluminum hydride, sodium borohydride, and you have seen uh, boranes. It's not borane. That borane, dicyamyl borane, BH3, those are borane compounds. But these are hydrides. Instead of taking lithium aluminum La or sodium borohydride, if you take dibal, dibal stands for diisobutyl aluminum hydride. There is one hydride. In lithium aluminum hydride, LiAlH4. But here only one hydride is there, and there are two isobutyl group. So diisobutyl aluminum hydride is called dibal hydride. It is soluble in toluene is the medium, and the star is meant for its structure. There is no other star here. Yeah. And then followed by acidic hydrolysis. These two steps will convert this carbon becomes aldehyde and nitrogen escapes as ammonium ion. Not escapes, converted to ammonium ion. This bond breaks. Mechanism I have not shown. Definitely via imine. So, but you have to take 1:1 ratio, 1:1 between acid nitrile, alkane nitrile and dibal hydride. Excess of acid, alkane nitrile results amine because imine will be further reduced to produce RCH2NH2. It goes via imine CH double bond NH. So you don't take excess of the substrate. Take 1:1 ratio, then only you get aldehyde from cyanide. Cyanide से हमने पहले which reagent we use to get ketone from alkane nitrile before? ଆଗରୁ ଆମେ କୋଉଟା ନେଉଥିଲେ କୋଉ ରିଏଜେଣ୍ଟ ନେଇଥିଲେ ଆଲକିଲ ସାୟାନାଇଡ୍ ରୁ ଆଲକିଲ ସାୟାନାଇଡ୍ ରୁ ଆମେ କିଟୋନ ପାଉଥିଲେ ହାଇଡ୍ରୋଜେନ ସାୟାନାଇଡ୍ ରୁ ଆଲଡିହାଇଡ୍ ପାଉଥିଲେ ହୁଁ
Sir, hydroboration oxidation করতে
I am so very sad today. ଖାତା ଦେଖିକିରି କୁହ ଏବେ ଗଲା ତୁମେ ଲେଖୁନ ବୋଧେ
Yes,
ସାଇନାଇଡ୍
lectures.
ସେଇ ସାଇନାଇଡ୍ ସେଇ ଏଷ୍ଟର ରୁ କିଟୋନ ହଉଥିଲା by using what? ଏଠି ଆଲଡିହାଇଡ୍ ହଉଛି ସେଠି କିଟୋନ ହଉଥିଲା ଏଠି ଆଲଡିହାଇଡ୍ ହଉଛି ସେଠି କିଟୋନ ହଉଥିଲା ତମେ ଏବେ ଗଲା ପରା Grignard reagent or dialkyl cadmium, the organometallic compound producing carbanion, that with alkane nitrile and ester, and of course acid chloride. All these three were giving ketone. मन पड़ला खाता देखो
Yes,
जनरल मेथड्स कितना नंबर पॉइंट ये सब तो
7
यस 7 नंबर पॉइंट HCl रो खाली आल्डिहाइड किंतु एठी सबुबेले आल्डिहाइड मिलिबो aldehyde to get acid alkane nitrile to aldehyde you have to use dibal hydride followed by hydrolysis 1:1 ratio. So same is the case with ester 1:1 ratio, but here we have to use little low temperature minus 78 degrees Celsius dry ice temperature so that we get better yield. Higher temperature and excess of ester forms alcohol. So it is empty amine, it is empty eight aldehyde eight तो alcohol होगा ये part तो alcohol alkoxy part alcohol होगा aldehyde part भी alcohol है जो तुम high temperature use करियो कि excess of alcohol use करियो नहीं excess of ester use करियो I'm sorry excess of ester use करियो but it ଆଉ ଗୋଟେ method ଅଛି dival hydride can also reduce carboxylic acid to aldehyde এইটা সিনা লেখা ହେଇଛି ପ୍ରକୃତରେ କିନ୍ତୁ ଏଇଟା ଏମିତି ହୁଏନି ସେଥିପାଇଁ ଡାଇରେକ୍ଟ ରିଡକ୍ସନ ନଟ୍ ପସିବଲ ସି ନେକ୍ସଟ ତେଣୁ ଏଇଟା କେତେ ଗୁଡାକ ବହିରେ ଲେଖା ହେଇଛି ଯେ ଏଷ୍ଟର ଏସିଡ ଆଲକିଲ ନାଇଟ୍ରାଇଲ ଭଳିଆ କାର୍ବୋକ୍ସିଲିକ ଏସିଡ ମଧ୍ୟ ଆଲଡିହାଇଡ୍ ହେଇଯିବ ବଟ୍ ଡାଇରେକ୍ଟଲି ହବ ନାହିଁ ଲେଖିଦେଇପାର ଲେଖିଦିଅ ସି ନେକ୍ସଟ ଯେମିତି ମୁଁ ଲେଖିଛି ତାକୁ ପ୍ରୋଟେକ୍ସନ କରିବାକୁ ପଡିବ ୟୁ ହାଭ୍ ଟୁ କନଭର୍ଟ ଇନଟୁ ଏଷ୍ଟର କରିବାକୁ ପଡିବ कार्बोक्सिलिक एसिड को एस्टर न कले डायरेक्ट कार्बोक्सिलिक को हम ना एंड डाइवाल हाइड्राइड रे तुम जो अनकंजुगेटेड नब ताहले किछि असुविधा हम ना अनकंजुगेटेड से गोटे एग्जांपल देछि जे डबल बॉन्ड जदि थिबो भी ताहले किछि प्रॉब्लम हम ना कंजुगेटेड थिले असुविधा पड़ सी भी रिडक्शन हो तेणु ये अनकंजुगेटेड जो थी डाइवाल हाइड्राइड ने डबल बॉन्ड आउ रिडक्शन हेनी ये ऑक्सीडाइजिंग एजेंट जो जोन रिएक्शन प्रोड्यूस से कहला भांगीदेव दे विल रप्चर द डबल बॉन्ड एठी नेले कौन हम सेटा भी डबल बॉन्डटा भी सिंगल बॉन्ड हो जोटा कंजुगेटेड रे जाए
Yes, sir.
এইটা जो कार्बोक्सिलिक एसिड को कौन करा जाए प्रोटेक्शन करा जाए ताकू एस्टर करा जाए यूजिंग दिस ट्राइमेथिल सिलाइल क्लोराइड ट्राइमिथाइल सिलाइल सिलिकॉन एटा क्लोराइड दे देले HCl पड़ेव सो सी डबल बॉन्ड ओ ये ट्राइमिथाइल सिलाइल ग्रुपटा लगे TMS ताको लिखिदेली मु ट्राइमिथाइल सिलाइल ग्रुपटा झुरीगला so it is trimethyl silyl ester so carboxylic acid can be first protected by reacting with trimethyl silyl chloride to form silyl ester trimethyl silyl ester and then reducing with dival hydride 1:1 ratio रे कले हबो एस्टर करियो पड़ियो कि जो बहिरे लिखि दी डायरेक्ट सेटा प्रकृति ठीक नुहे से दीटाक लिखिली केतोटाक जदि डायरेक्ट लिखुथबो सेटा भूल जदि भूल जापर सी आलडिहाइड हम आउ गोटे रिएजेंट अच्छी जोटा बहुत रेयरली करा जाए डाइवाल भलिया लिथियम ट्राइथक्सी आलुमिनियम हाइड्राइड मध्य केवल आल्किल सियानाइड को करदेव आल्डिहाइड आमर कौन दरकार आम डाइवाल हाइड्राइड तो अच्छी डाई आइसोब्यूटाइल आलुमिनियम हाइड्राइड ସେଇଟା ହେଲା କାହିଁକି ଆମେ ନବା ଲିଥିୟମ ଟ୍ରାଇଥକ୍ସି ଆଲୁମିନିୟମ ହାଇଡ୍ରାଇଡ୍ ତଥାପି ଏଟା ଗୋଟେ ସବଷ୍ଟିଚ୍ୟୁଟ୍ ଅଛି ଫର୍ ଆଲକିଲ ସିଆନାଇଡ୍ ହେଲା
Yes, sir.
এইটা লিখে দরকার নেই ডিএমপি অলরেডি শোন ইউ যেমতি পিସିସି ক্ୟାନ୍ ୱାର୍କ ୱିଥ୍ ଡବଲ ବଣ୍ଡ କଞ୍ଜୁଗେଟେଡ୍ ଡବଲ ବଣ୍ଡକୁ କିଛି କରିବନି ଏଇଟା ଗୋଟେ ଅନକଞ୍ଜୁଗେଟେଡ୍ ଅଛି ତାକୁ ବି କିଛି କରିବନି କଞ୍ଜୁଗେଟେଡ୍ ଥିଲେ ବି କିଛି କରିବନି ଅନକଞ୍ଜୁଗେଟେଡ୍ ଥିଲେ ଆମେ କରୁନଥିଲେ କଞ୍ଜୁଗେଟେଡ୍ ପାଇଁ ୟୁଜ୍ କରାଯିବ ଜୋନ୍ସ ରିଏଜେଣ୍ଟ ନାଇଁ ସେଇଟା ସେକେଣ୍ଡାରୀ ଆଲକୋହଲ ପାଇଁ ପ୍ରାଇମେରୀ ଆଲକୋହଲ ପାଇଁ ଆମର DMP is very very important, is very useful, more useful than PCC. It will retain conjugated and unconjugated double bonds in making a 1 degree alcohol to aldehyde and 2 degree alcohol to ketone. This is best reagent for both conjugated and unconjugated double bond. এটা তুমি লিখে দেবো পরে জায়গা ছাড় দিও এটা ইউজুয়ালি কেହି କରନ୍ତିନି DMP एंड ଏଇଟା ଗୋଟେ ଆଉ ଗୋଟେ ଜିନିଷ ମୁଁ କହିବାକୁ ସେଇଠି କହିଦେଇଥାନ୍ତି एसिड क्लोराइड रे जेमती ग्रिग्नाइट रिएजेंट देले हुए सेठी गिलमैन रिएजेंट देले भी हबो डाइअल्किल क्यूप्रेट लिथियम डाइअल्किल क्यूप्रेट व्हिच इज प्रोड्यूस्ड by using lithium aluminum sorry alkyl halide lithium and cuprous chloride CuCl or CuX. By combining this you get Gilman reagent. We know the Corey house synthesis the first step. That Gilman reagent will one of the carbanions one of the R dash minus will be attacking and the way I told you to get ketone. এটা যদি ଆଉ ଗୋଟେ alkyl halide ସାଙ୍ଗେ reaction କରିଥାନ୍ତା you would have got R dash କିନ୍ତୁ acid chloride ସାଙ୍ଗରେ RCO R dash so that it becomes a ketone similar to Corey house but here you get ketone instead of alkane এটা ବି ଘରେ ଲେଖିଦବ. Okay, this is all for today. But before we go say goodbye, let us go for some SAQ. ଦେଖ ସବୁ practice you have to make. Excellent. Have you written the questions?
Oh, sir. Yes, sir.
ଦେଖ for saving time এটা কোন হবো?
Sir, aldehyde হবো, CH3CH
Yes.
ethanol.
And aldehyde রে গ্রিগনেট রিএজেন্ট দিলে কোন হবো?
Sir, alcohol.
কি alcohol?
The secondary.
Yes, এইটি এই CH টা CHOH ହେଇଯିବ and a grignard reagent ଲାଗିଯିବ. So this is isopropyl alcohol. Then ତାକୁ Jones reagent ଦେଲେ କଣ ହବ?
ପୁଣି ketone ହେଇଯିବ।
Acetone. So 2D alcohol and oxidation gives ketone. ପୁଣି ketone ରେ ଯଦି grignard reagent ଦେଲେ କଣ ହବ?
ପୁଣି ଆଉଥରେ alcohol।
କୋଉ alcohol? ସେଇଟା କହିବ
Tertiary।
tertiary alcohol. ଲେଖୁଛ ତ?
Yes, sir।
And on copper heating କଣ ହବ?
Elimination of tertiary।
Alkene ନାଇଁ?
Yes, sir।
So it produces same dehydration ହବ. Dehydrogenation ନ ହେଇକି dehydration ହବ. ବୁଝିଲା?
Yes, sir।
ଦେଖିସାରିଲଣି?
Yes, sir।
ଏଇଟା 2 ନମ୍ବରଟା କଣ ହବ? Acid chloride with grignard reagent. କଣ ହବ ଏଇଟା?
Sir, alcohol ହେଇଯିବ।
ଆଲକୋହଲ କେମିତି ମ?
ନାଇଁ ସାର୍ ଏସିଡ୍ ହେଇଯିବ, ଏସିଡ୍।
ଏସିଡ୍ କେମିତି ହେଇଯିବ ମ? ତମେ ଦେଖ କିଟୋନର 7 ନମ୍ବର ନା କେତେ ନମ୍ବର ପ୍ରିପାରେସନରେ ଏବେ ରିଭାଇଜ କରିଥିଲେ ଏସିଡ୍ କ୍ଲୋରାଇଡରୁ ଏଷ୍ଟରରୁ ଏବଂ ସାଇନାଇଡରୁ ଏ ତିନିଟା ଯାକରୁ ଗ୍ରିଗ୍ନାଇଡ୍ ରିଏଜେଣ୍ଟ ଦେଲେ ହବ କଣ ନା କିଟୋନ। ଦେଖ ଖାତା ଦେଖ 7 ନମ୍ବର ପଏଣ୍ଟ। ତୁମେ କହୁଥିଲ 7 ନମ୍ବର
Yes, sir।
ତୁମେ
Yes, sir। ସେ ketone ହେଇଯିବ ସାର୍।
एसिड क्लोराइड नहीं जहाँ थी Cl माइनस टा पळेबो एठी अल्कोक्सीटा जहाँ थी जेते मोटा थी से पळेबो आउ एठी साइनाइड रे तो अमोनियम आयन हे जिवो सो कीटोन हबो केवल हाइड्रोजन साइनाइड से कथा किछि न सेटा सो ए विल बी कीटोन कौन कीटोन ब्यूटान 2O नहीं
Yes, sir।
ACH3 टा लागि जिवो एठी तापर सरला एटा डाइसियामिल बोरेन विथ ऑक्सीडेशन कौन हबो एटा
Sir, aldehyde ହେଇଯିବ।
aldehyde हबो CH2 CH2 CH2OH ନୁହେଁ
Yes, sir।
ଏଠି CH ହେଇଯିବ ଗୋଟେ ସେଠି CH2 ପୁଣି CHO କଣ କିଟୋଇନୋଲ ଟଟୋମେରିଜମ ହେଇକରି aldehyde I'm sorry CH2 then CHO ହେଇ ହେଲା ହଁ
Yes,
ଦେଖ
sir।
ଆଜିକାଲି କରେକ୍ସନ ବି ମୋର କରୁନ ଭୁଲଭାଲ ହେଇଯାଉଛି ମୁଁ ହିଁ କରେକ୍ସନ କରୁଛି 1 2 3 4 ବ୍ୟୁଟାନାଲ ବ୍ୟୁଟାନାଲ ହଉଛି A PCC ଏଟା A ଆଉ PCC ଦେଲେ କଣ ହବ
ଏସିଡ୍ ହେଇଯିବ।
ନା 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 PCC ACC ମୁଁ ଭୁଲ ଦେଇଛି ଏଠି ତାପରେ କଣ ଦେଇଛି ନାଇଁ ଏଇଟା ଏଇଠୁ
ସେତିକି।
ସେତିକି ନାଇଁ ଏଇଟା କାଟିଦିଅ PCC can work with secondary alcohol to ketone but aldehyde को carboxylic acid କରିପାରିବନି PCC जोन्स रिएजेंट କରିଦବ କିନ୍ତୁ ଏଇଟା କରିବନି ସो ସେଟା କାଟିଦିଅ ଆଚ୍ଛା ଏଇଟା କଣ ହବ it is SN2 reaction ରେ କଣ ଏଇଟା
Sir,
sorry
night।
so this is ethyl cyanide ନାଇଁ
Yes, sir.
प्रोपेन नाइट्राइल ଆଉ ବର୍ତ୍ତମାନ ଆମେ ପଢିଥିଲେ ଷ୍ଟେଫେନ୍ସ ରିଡକ୍ସନ ଏବେ ପଢିଲେ ଷ୍ଟେଫେନ୍ସ ରିଡକ୍ସନ ହଁ କି ନାଇଁ ମ
Yes, sir.
କଣ ହବ ଏଇଟା ବିଟା
Sir, aldehyde ହେଇଯିବ।
so propanol ହେଇଯିବ ଷ୍ଟେଫେନ୍ସ ରିଡକ୍ସନ ରେ cyanide with stannous chloride HCl acid hydrolysis gives aldehyde then aldehyde ରେ ଗ୍ରୀନ reagent ଦେଲେ କଣ ହବ ଜାଣିଛ ସି ଟା ହବ ସେକେଣ୍ଡାରୀ ଆଲକୋହଲ ନୁହେଁ
Yes, sir.
CH3 CH2 CHOH then CH3 ତଳେ ଲେଖି ଦଉଛି CH3 ବ୍ୟୁଟାନ 2 ol ହେଲା
Yes, sir.
ଏଠି ଦେଖେଇଛି ଯେ ବ୍ୟୁଟାନ 2 ol ମଧ୍ୟ ପିସିସି ଦ୍ୱାରା ଅକ୍ସିଡାଇଜ ହେଇକିରି କଣ ଦବ ବ୍ୟୁଟାନ 2 ol ମଧ୍ୟ can be oxidized by PCC to give what अरे सेकेंडरी अल्कोहल ऑक्सीडेशन हेले दब कौन
Sir, ketone।
तो ब्यूटान 2 नहीं
Yes, sir.
तापर लास्टटा होची ए डाइवाल हाइड्राइड देले कौन हबो एस्टर हो कि हबो कौन हबो एटा एटा पळै हबो ए कौन ही जो एठी एटा कौन हबो एसिड एल्केन नाइट्राइल आरसीएन हो कि एस्टर हो डाइवाल हाइड्राइड देले कौन हबो
Sir, aldehyde ହେଇଯିବ।
ଆଲଡିହାଇଡ୍ ହବ ଏଇ ଗ୍ରୁପଟା ପଳେଇବ ପୁରା CH3 C ଡବଲ ବଣ୍ଡ OH ମନେ ପଡୁଛି
Yes, sir। ଆରଟା alcohol।
କେତେ ନମ୍ବର ପଏଣ୍ଟ
12 ନମ୍ବର।
यस एस्टर देले भी ये पळेबे एटा अल्कोहल ହେଇକି ପଳେଇବ वी नो वी डोंट बॉदर अवश्य ମୁଁ कंडीशनଟା ଲେଖିଲେନି एस्टर ମାନେ -78 डिग्री सेल्सियस को ड्राई आइस टेम्परेचर नବାକୁ ପଡିବ एस्टर ରୁ डाइवाल हाइड्राइड हेले -78 डिग्री सेल्सियस हेले एसिटाल्डिहाइड ହେଲା ଆଉ ଆରଟା ଇଥାଇल अल्कोहल ମୁଁ ଲେଖିଲିନି ଦୁଇଟା ପ୍ରଡକ୍ଟ ଅଛି ତମେ କହିବ କେମିତି ଆପଣ ଆମେ କେମିତି ଜାଣିବା ହେଲେ ବି ଆଉ ଗୋଟେ ଲେଖିଥାନ୍ତି ଆଉ କଣ ଦେନ୍ ଆଲଡିହାଇଡ୍ କୁ ରିଡକ୍ସନ କଲେ କଣ ହବ ଦିସ୍ aldehyde on reduction gives what
alcohol।
କି alcohol
primary।
eh primary yes 1 degree alcohol ହବ this is ethyl alcohol ତାକୁ सोडियम ଦେଲେ କଣ ହବ सोडियम salt
Yes, sir।
and tert butyl chloride ଦେଲେ କଣ ହବ ଆରେ
Sir,
सोडियम yes 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 କଣ
elimination ହବ ଏଟା alcohol ହେଇଯିବ।
ହଁ ଏଲିମିନେସନ ହବ ଏଇଟାର ଆଉ ଏଇଟା H ନେଇକିରି ଏଇଟା ଆଲକୋହଲ ହେଇଯିବ ଆଉ
alcohol ହେଇଯିବ।
100% elimination product habo from tertiary halide with a strong base like alkoxide ion. So we close today's session and तुमे टिके organic रे out के कामो करो to make me happy so that as you have been doing so far you also will do it and those who will be watching who are watching now not now when the class is actually going on it's not a live program it's a recorded program but who are watching and if you are benefiting, then please don't hesitate to hit a like button and share this video and also don't hesitate to I was saying don't subscribe. How funny. Don't hesitate to subscribe my channel SST Chemistry. Bye bye. ତମର କିଛି ଡାଉଟ୍ ଥିଲା କି ରୁଦ୍ର ମୋ ପାଖରେ
No, sir।
ଓକେ ସୋ ସେଥିରୁ କର ଆରମ୍ଭ କର ସେଥିରୁ ଚୌହାନରୁ ଯୋଉ ଡାଉଟ୍ ସବୁ ପଚାରିବ ବାଏ
Okay। Yes, sir। ପ୍ରଣାମ, sir।